So welcome to TCoffeeAndCode, all about threading and concurrency. And I tell you what, I am really excited because of the panelists we have today. You guys know your stuff. Hey, Frank, when it comes to threading and concurrency, so I know I will definitely be learning a lot today. One thing, just real quick, this is a informal conversation, and just that, we're all sharing our opinions and things change, and we're not necessarily speaking for any company or organization. So if, take everything what we're saying with a grain of salt, as it were. So our panelists, Promoz, Olaf, Kevir, Dahlia, and Frank are all online with us now. Actually, oh, you know what, Frank? I gave you Kevir's link. How did I do that? So Frank is listed as Kevir.
I got the wrong name, right?
Yeah. Can I rename you? Let me give you a different link. Hold on.
I'm sure they're beautiful, more beautiful now, Frank. You sure, Kevir? I'm sure.
And Frank, we are all on 4 to 3 screen sizes. Maybe you can change that too. It's in the settings.
Yeah. Why you on? Okay, whatever.
It just squares it up when you have a bunch of them together here. It
Yeah.
gives zoomed in, cropped mode.
It's up in the settings, and there's a video and audio setting, and there's it's a radio button.
And I just sent you a different link if you want to rejoin with the other one.
Okay.
The right name. Since I don't be able to appear to rename you. Frank disappeared. It hopefully comes back. Okay, so Promoz, I'll let you go ahead and introduce yourself real quick. Just say a couple of things about yourself. Everybody can obviously read the screen, but anything you want to elaborate on there?
Well, I started programming in high school and still doing the job now. That's more than 30 years later.
Yeah. So is it, I know for me, I just knew, when I was very young and started programming, I just knew it's like, this is what I'm going to do.
Yeah, most definitely. Yeah.
Yeah. It's like, I don't know what this looks like. I'm not sure what the career looks like, but it's going to involve computer programming.
My career looks like, I basically just like I started with my father's pocket calculator. He got his HP 41 with magnetic card reader. And one of the programs that came with the reader was moon landing simulation, which said, how much fuel will you inject? And you type the number, then it will say you're moving with this speed and this height, and how much fuel will you inject now? And you tried to land, and I always crashed. So I checked the assembler codes of that program, found out how it works, and wrote a formula which generated precise number of fuel I needed to land. And I'm still doing this now, 30 years later. This assembly stuff which doesn't work, and fix it in my code.
Fix it, yeah, absolutely. That was probably a single-threaded application, though. I take it.
Very certainly.
Okay, Olaf, real quick.
Yeah. Hey, yeah, my name is Olaf Monian, and I jumped into the Borland world of programming with Turbo Pascal 3, I believe. That was still at school, and well, I somehow found that there is Delphi, and I started off with Delphi 1, of course. I didn't leave or didn't skip Delphi 8, so I still have a CD somewhere. Was actually signed by David I, and back then we thought it's gonna be the greatest thing of all. Turned out not to be. And then, of course, I'm still here, and well, I do consulting well, obviously in the world of Delphi and software development, and that's what I do for a living. And I'm the owner of Developer Experts with an office in USA and Unternehmensberatung Monin here in Germany, where I'm an Embarcadero MVP, actually coordinator for the German-speaking region, and contributed to a couple of libraries in the intraweb. Actually, the REST client library is mostly done by me, and the Bash components. And well, I have an email if anybody has a question to whatever you think might be questionable, what we're gonna talk about, and just feel free, send me an email. And of course, I have a blog, which is on the screen. So yeah, I'm interested to see what we're gonna talk about. And as I can see, many other very experienced Delphi programmers, especially with threading. So it's gonna be interesting today, I guess.
Yeah, I'm excited too. Kevir, real quick, tell us a little about yourself.
Hello. Well, you can see this is me trying to take a Superman picture, but as you can see, I wasn't able to be serious enough. Well, I am a developer since 2001, and I'm regional coordinator for the Embarcadero MVP here in Brazil, and MVP since 2014. Speaking on events since 2009, and today I'm at Edus, that it's a company that focuses on educational business, and I'm working as the lead product architect. In this role, I actually I'm not coding too much, but I can't be away of coding. So I used to code hobbies and this kind of stuff, but I'm dealing with code every day. So here are my contacts. I used to say that my name is a kind of primary key. So if you Google by Kevir, probably you'll find me. And feel free to stay in touch if you want.
Fantastic. So is developer, is that I thought it was a typo, but is that a word for a Delphi
No.
developer? No?
Yeah, it's a new word. It's Delphi developer. So it's an acronym that you can use if you want.
Neat.
A developer.
Developer. I like it. I like it. Dahlia, real quick, tell us a little about yourself.
Oh, hi. I started programming in True Pascal in high school, like many other developers here, and specifically on CPM on Iskra Delta computer. Primož will know about it, I'm sure. And then I was an IT writer and editor for computer magazines in Croatia. And this is how I started my writing career. Later on, I moved on to programming for web, and actually I was using Java before I started to use Delphi. And I landed on Delphi since version 4, and I'm still here. And now I'm writing books, answering people's questions on Stack Overflow, hanging on Delphi Praxis, and so on.
That's great. I'm glad that you're part of the community now and contributing in so many ways. That's fantastic. And Frank, that's now Frank instead of Kevir. So
Yes. Yeah. Hello. My name is Frank Lauter. I'm like Olaf here from Germany, and yeah, I started very early with Turbo Pascal 1 and on CPM. It was the early days where you have to put in a special hardware card in many computers to expand your screen from 40 columns to 80 columns to just be able to run CPM. And this was also the days where you can have Z80 card for an Apple II to run CPM on a slot card in an Apple. And yeah, this was the early days. And today with the topic of threading, Olaf would also know this fact if we have a talk here in Germany, like from Delphi Praxis or from Embarcadero or whatever. We have meetup events where we meet other developers here in Germany, and one topic that is always on the table, it's about threading. And I like to start these talks with a little joke. So the boss asks the lead developer, "Oh, I recognized if I use our app and connect first time to the database, and the database is connected over the internet, there's the app freezes. So could we take a thread for this connection?" And the lead developer says, "Oh, normally yes, but threads is Peter is doing threads in our company, and Peter is on vacation, so we have to wait to make this connection in a thread. Peter has to do this because nobody else knows about threads in our company." And I think this is so funny because it's not a joke. Most developers, and that's especially before we get the I call it TTaskRun feature, so the threading library included in Delphi. Before that, you have to write your own thread for everything, and the conclusion on that was that really nobody uses threads in application. And as we all know, we don't get soon CPUs run on 10, 15, 20 gigahertz because of the speed of the light internally. So the only possibility to get our application run faster is to split the source code or to split the execution to many threads, and that's it. So I like this topic very much. So I'm thankful to Jim that he invited me to this talk.
Yeah, my pleasure. Glad you could join us. I was expecting some sort of punchline to do with race conditions, that he was like trying to talk to this guy, but he couldn't talk to this guy because
Actually, it's a quite interesting.
Peter is the race condition here. We have to wait on him.
So we will have to synchronize somehow who is going to speak.
Multithreading troubles.
Yeah. So
yeah,
you can just call enter.
I'm just real quick introduce myself, and then we'll start into the conversation. Just in case no one knows who I am, Jim McKeith, developer advocate and engineer here from Embarcadero, longtime developer, started in Pascal 3, and I didn't actually use Delphi 1 until later. I discovered Delphi during Delphi 2. But been a Delphi developer, well, used a lot of languages, but I just love Delphi, and so I keep going back to using Delphi. So as we start the conversation here, just let everybody know this is a Q&A conversation, informal panel. Put your questions in the question panel there, and I will do my best to present them to the attendees or the panelists so that they can answer them and provide their thoughts and such on those. And we will form our conversation around that, and clearly try and do our best not to cut each other off and have synchronization issues here with the panel conversation. But I'm going to go ahead and let's go to Olaf, because he had something he wanted to say there and share with us, and we'll start discussing this. What are we going to say, Olaf?
Yeah, like Frank said, it's really like the I met many developers who really think that threading or multi-threading is the holy grail of programming. They would never touch multiple threads. So some developers just jump into the big pool and try it. Some very successful, and what I can see is, since we all use those small devices, we are all in some way more attentive to our applications, that they don't get stuck somewhere because you just press a button that calls a database and that takes a minute or two. And because these small devices that we all carry around, if there is an application and you press a button and nothing happens for a while, you just kill the application. That's something the users that we programmed for back in the days was just Windows never would do. They knew if I press the print the report button, it will take 5 minutes, and I go for a coffee and wait for the report, and I won't touch the program while it's preparing the report. But that changed, and many developers are really more into the world of multi-threading and making applications responsive, so that you don't have to wait for a button to respond. So it should prepare, should send a message. Oh, I'm preparing the report, and the report is somewhere running in the background. That's basically what most of the developers seem to understand now. That's something that we need to achieve. And well, maybe one of the questions I've seen here in the Q&A room is already about T-task and thread, where's the difference and everything. So it seems there are new technologies that we can use, and it's still unclear where the differences are. So we will have to talk about T-task and T-thread in a bit.
Actually,
I think I read a white paper about responsiveness of apps, and the author says if you have an app that is not responding on a button click in under, let's say, 250 milliseconds or 500 milliseconds, most of the users think the app is crashed and just try to kill it out of the RAM. And we never saw this in Windows in the past. So you're absolutely right. I think especially for the mobile development, using threads and using, especially with FireMonkey, you have to do nearly 99% in threads and just keep the main task for the FMX kernel to draw the UI, and that's the goal.
Yep.
Yes, on Android, you even have to use threads because you cannot access network or run web service from the main thread. It will throw exception, network on main thread exception. So you're prevented from the OS to do that. So it is forced by the OS to use threads and to keep your application responsive. So this is something that we are not used on Windows as Windows developers, and that is the first thing anyone tries is how to disable this feature on Android. But instead of disabling it, there is a way to do that. But instead of disabling it, you have to learn how to use threads. That is the only way.
Yeah, not allowed to block the main UI thread for more than like any period of time. So you should just use the main UI thread to dispatch things. It is certainly a shift to learn that, but I think it does benefit the user to have a more responsive application for sure. So I did want to bring up
about this responsiveness in the Windows world or desktop world. The worst thing you will get is your screen frozen and the title changed to not responding, and you just wait. But on the mobile world, the app will just crash, and the OS will kill your app. So in fact, you need to do this.
Yeah.
And I see a real tendency that all this, what we learned on the mobile devices, is actually pulling back to the to the desktop applications. So I see more and more desktop developers asking for how can I do that it really behaves like on a mobile device.
Yeah, absolutely. So apparently I'm having some audio issues. Olaf, let's go ahead and go to you and
Yeah,
start.
you're scratching.
You brought up the T-thread versus task. There was a question here from Iwan.
Yeah, I saw a question here from Ivan Sugeng. I have no idea how to pronounce that, but he is asking, can you tell me in simple words what is the difference between thread and T-task, and how to use another core? Is it automatically handled by the thread or not by the, or actually is it handled by the task or by the thread? Okay, the difference between T-task and T-thread. Well, T-thread is basically the wrapper of threads in Delphi. So this is the core class to implement threads. And that's what we had up until, I think, XE5 or so, when the parallel library was introduced. And
seven,
six,
I think.
Yeah, close shot. Up until then, we had to basically program a new thread class that overrides the execution or execute method, and all the thread code would run in that special method. So it was kind of a very secret science to do that, obviously, because many users, like Frank basically told us in his joke, had only one developer in the company who knew how to handle a T-thread, or actually a class descending from a T-thread. So this is the actual thread class. Then later in XE6 came T-task. T-task is basically a comfort zone for thread developers because it wraps T-thread in some way. It's not just T-task. There is a pool, so a pool of threads. These threads in that pool are of course T-thread descendants, and T-task provides an easy-to-use interface to create your own running thread. It has a specific method called run, and in that run method, you can pass in some code, and that code is then just taken and will run in the background thread. And not just so, it's gonna pass to a pool, and that pool or the pool manager will check how many threads are actually currently running already, and make sure there is no overload of threads, because I mean you can have like 1,000 or 10,000 threads in your whole system. That's not a problem for modern computers. Somewhere it still pops up, there is a node saying, oh, you can't have more than 64 or 16 or 32 threads. That's nonsense. You can have as many threads as you want, but if you have too many threads at the same time being active, it may be that there is an overhead taking most of the time, because you have to pass the thread context over and over again too many times, and that may be, well, not very efficient. So the pool handles the situation that your current process will only have like maybe 20 actively running threads. So T-task will spawn a thread, and the pool manager in the background controls that not too many threads are active at the same time, and it keeps, if you can put in more and more threads in, or T-task instances in there, and the pool will put them in a queue waiting to be executed if there is already the maximum number of threads running. And that's something you don't have if you're just using T-thread, because with T-thread, you are all on your own. So T-thread is the core of threading, and T-task adds quite some nice, handling that you can use, and it's always up to you what to use. So yeah, so it's not really a difference. It's a different level of framework that you're using with T-task and T-thread.
It's a different level of abstraction, yes.
Yeah, I recently talked to a developer, and he asked me, "Oh, you have created so many threads, but my main CPU has only six cores. I say, okay, what do you want to say? His understanding was, if you create a thread, you own one of the cores, and that's not the point. And I think that is the one major misunderstanding about threading. You don't own one core if you just create a thread. You create a little time slice of the CPU, perhaps, if the zero task from Windows or from the OS will give you some calculation time, and that's it. And I think the main difference, and there are a lot of questions already popped in. If you, I want to answer one of them. If you can loop in a thread, polling a device, of course you can do this. And I think the main trick with right thread handling is just pull something if there's no better method to do this, because if you have more than 6, 5, 10, 20 running threads, you're wasting CPU cycles. Most of the threads should wait on something like an event or some other external input to run and then sleep again. And with the TTask stuff Olaf just explained, you don't have to deal with this kind of thinking, because you create your TTaskRun stuff, put a normal procedure or direct in the brackets the procedure, and the execution of this little part of your source code is just run if the scheduler or the manager of the thread pool has an empty space to give you this time slice and execute your procedure.
Yeah, I would say if you have a long-running task that runs almost through entire application lifetime, then it is probably better to have dedicated thread to run this particular task. But if you have some short tasks and short operations you are operating that are independent, then using TTask is the best thing to do.
So a word here. Basically, what you're talking is running a task versus scheduling a task. And in parallel programming library, in Delphi, you can only schedule a task. That's why you are still creating a thread for a long-term thread, but this can be improved in the future. If you use Omnithread library, sadly Windows only, you can do run or schedule and you're done with it. You don't have to deal with threads anymore. You can just use tasks. But PPL is built around scheduling everything into TaskPool. Yeah. So that can be an advantage and that can be a problem.
Yeah, basically you don't know when exactly your run is actually, or the code in the run procedures actually executed, because it's going to be it's going to be pushed into a queue. That's what the scheduling means. And if nobody is in front of you, it will be executed almost instantly. But sure,
you can, but now we're getting technical with parallel programming library. So for people who don't know this stuff, in Delphi you have something called parallel programming library, which is part of the system.threading unit, and you can create a new pool. So you have 4 long tasks. You can just create a new pool, say please execute 4 tasks in parallel, and then you schedule your tasks into this new pool, not into the standard pool, and they will execute immediately. So you can know that, but you have to work around it.
Yeah, but I hope we don't get misunderstood here, because please don't create 100 pools or so, because that would completely undermine the idea of the pooling, because if you have 100 pools, every pool with like 20 maximum 20 running tasks, then well, the whole pooling is gonna be a dead end. So if you create your own pool, exactly know what you're doing. That's probably the best thing how to put it.
We always come to the same point. Sorry,
yeah.
With multi-threading, you have to know what you're doing.
Yeah, and there's actually
you can have a nice helper library, but it will not help you if you're doing things against it. So please.
Yeah, but my rule of thumb between using a dedicated thread where you just create a new class dependent from thread and you using the TTaskRun stuff is I use this TTaskRun stuff only in these places where you can execute code like shoot and forget. It's a closed task. You have to whatever make a REST call. The REST call comes back. You have your information, and the thread is gone. In this case, sometimes I use a TTaskRun method, and if I have something, especially if it's time critical, I would create a normal thread class that is waiting on an event, because if I have the event wait for inside the execution main loop, where you normally say why not terminate it do, you can have this thread running in the background, and the thread don't waste any CPU cycles. And if the external event occurs, the thread started immediately. And if I mean immediately, we are talking about not nano, we are talking about picoseconds to start the thread without any overhead. And that's the main deal with creating a waiting thread, I call it.
Right, and there's actually a question from Javier, or a statement, or what? When you create a thread, you place it in a pool, as I understand. No, you don't. If you create a thread, a T-thread instance, it's not going to go into a pool. It's like Frank said, it's just something, it's an execution object, and that will start right away. And like Glenn actually mentioned, it's handed over to the operating system, of course, and the operating system takes control of the underlying scheduling, of course. So there is no scheduling for T-thread instances in Delphi, but the operating system takes control there, as of every thread object written in whatever language. So we always have those two layers here, so don't mix them up. And if you're using TTask, it's Delphi's own pooling system, and eventually every TTask ends up in a T-thread, and that's handed over to the operating system then, of course.
Yeah, but you don't know when it will happen when you're using TTask. Right. That is the main difference.
Yeah, there's another question from Stefan Bentol, I think. He asked if you want to do multi-threading, if your CPU must be capable of it.
No.
Yes, of course, but
no, why?
It's not a CPU related binding from the thread to the CPU, because the CPU just follows the instruction, and the operating system is able to take the 100% CPU cycles and switch between the different task content.
Well, so no, every CPU is multi-threading capable. It's the OS which supports multi-threading, yes, or not. And you can easily run multiple threads on a single core, because OS will do just what it did 20 years ago when we had only one core, but we were running 50 programs in Windows at the same time. It will put a little slice of time to each thread. So it is not CPU related, and you can run this everywhere Delphi runs. So no problems here. And Jim, you're mute.
And maybe in the same direction of the questions, there is a question from Chris Peters. He is asking, is there an async event that fires when the task starts or ends? Thread safe, of course. No, that's something you have to implement. So it's something, it's very common that you implement some unfinished event handler on error event handler, or maybe even an on start event handler. So it's something that's up to you to implement. If you don't need it, you don't have it. So that's basically how it works. So it's something that you need to put into your code. And if you want to say thread safe, well, you have to make sure it is thread safe. There is always some work or effort related when working with threading.
Well, the simplest way. Sorry,
has
Dahlia.
on terminate event that will run on main thread after the thread is finished. But that is the only thing there is that will notify you that thread has finished. You cannot use that with TTask. This is only for TThread class.
Right.
The simplest way to notify the main thread that something happened is to just use tthreads.q from your thread and post a notification to the main thread. It will be executed safely, synchronously, and you just pass an anonymous method to tthreads.q and you're done.
There are actually several, I've seen many libraries or functions that somehow use threading or tasks inside of them, and they want you to put in 3 methods, like the actual execution code, then the actual when it's finished code. That's very common because you somehow need to know when it's done, and you often see an on error or on exception input that they want. So that's usually the 3 cases that you have to or that you want to be implemented.
Well,
Hopefully my audio.
That is useful thing to have, and it is usually used in futures, various implementations, where you start you start a future that will execute asynchronously, and then you have callback methods on error or on success, and they will fire depending on whether your future has been calculated, your value you want to calculate at some point in time, whether it has been successfully calculated or not. So this is a quite common scenario.
Just for my curiosity, of course I have threads and I put something in and the thread is running and I get a notification if the result is done, and I can use query or synchronize to inform the main thread. But Dahlia, do you really have a nice example for a future? Because normally in these cases where I want to try to implement something to use this feature, I run into at the point in code where I create a future. This is normally too late because at this point I need the result. So this to make this asynchronous with an iFuture from Delphi, I never get used to an iFuture. I normally have a task or already a running task or waiting task, and I give an asynchronous procedure a callback, and I'm done. But the iFuture thing from Delphi, I've really never used in real life.
Well, Delphi future is a bit different from that on error and on success future with callbacks, because that future runs asynchronously and it will give you results through callbacks. So when you call the future, you will only get result in callback, not in the next line after that you call that future. And the Delphi future is blocking future. It will it is like running a task and then waiting on that task. So you cannot call that future in the main thread because you will block main thread. But if you run it in the background, you can have several futures running. You can wait until they are all calculated, and they will execute sequentially.
Yeah, yeah.
I have some examples on my GitHub account, some code examples from my book that talk about Delphi future, and I have my implementation that uses callbacks. So you can find
the callback stuff is really neat, but this Delphi implementation of an iFuture where you create this future and okay, this will compute one time, and the main thing of this iFuture implementation Delphi is you create the stuff, do something different, which takes some time, and after that I come back to my interface var and get the result. And if the result is there, I get the result immediately. And if the result is not there, okay, I have to perhaps wait not the full time, but the last 2 milliseconds.
Yes. Usually this is useful if you have if you can do some other operations in the meantime and you don't know exactly how long that future. But if you if you need that future result literally in the next line, then it doesn't make too much sense to.
Yeah, that's my point.
With
a callback you are fine, but with this, okay, I create this stuff, do something else, and then get my result in 10 lines, 20 lines below. I never found any kind of real life application to implement this with a callback, of course, yes. But this
the closest I came to was when you try to fetch few URLs from few different sites at the same time, and instead of writing some complicated task for all that, you just create 3 futures and wait on the first one. The program will still block while the HTTP GET is executing, but the other 2 will be executing in background at the same time. So you get the first response, and then you get the next, which is probably already there, and the third one. But it's not really useful. Yes, mostly you use some task in combination with events or something. Or in Omnithread library, you have async.await, which executes a piece of code in background, and when it is finished, it executes another piece of code in your thread, synchronized. So it goes ping, ping, or something like that. And you can also do this with parallel programming library. I have an example in my book how to do that. Please, Olaf.
I guess there are a few attendees already thinking, what the heck are they talking about? There's actually another question. Why doesn't Delphi, why isn't there a await implementation in Delphi? That's a question from Dimitri. And it's basically the same thing.
Compiler for that.
The whole thing with futures and await is basically the idea that you have methods that by themselves somehow execute asynchronously. So you have a method that does something, requests something from a REST API, then the next method does something with a database call, and the third call or the third method that you are going to call would call another REST library. So the idea of futures or the await thing is that you can build code that goes step by step. So the first operation and then mark it with await or put it into a future is like call REST API, and that runs in the background, not in the same context as your own thread, and then block the execution of your current thread. That sounds somehow weird, but it's basically the exact idea. Make your code step by step, blocking step by step, and the actual work is done in the background by every single method, and those methods need to be implemented asynchronously. And other frameworks or other languages, even JavaScript, have a completely different concept there. So you can mark your own method which calls these three sub-methods, these three asynchronous sub-methods. You can mark your own method in other languages to be asynchronous or async. So, and then the compiler knows, oh, this method itself must be put into its own worker thread. And that's the whole concept of futures and the await keyword that is used, for example, in JavaScript. And this is something which is, or the futures are put into Delphi because of other languages. And TMS software has a web framework, TMS Core, Web Core, and they provide a way to execute Delphi code translated to JavaScript. And they recently implemented the await keyword for Delphi for Pascal. But in the end, it's not executed in Windows or in Delphi. It's translated to JavaScript, and for that reason, it made sense to them to introduce the await keyword in their library, because they have a way to mark this executing main method as async itself, and the compiler, the JavaScript compiler that takes the Delphi code, translates it to JavaScript, will know what to do with it. So in Delphi, without external libraries, you would have to think of a containing thread, and there you put in your futures. That's basically the idea. You would never use that from main thread. It simply doesn't make any sense there.
Okay. I think the topic is with C#, where you have this async await stuff, where you have normal linear code, but the code is executed in the background. And
exactly.
To end this stuff about the feature, if you ever saw a different library, I don't know exactly how Omnithread is working, but for the mobile stuff, and I have done 2 years ago a talk about a threading pipeline, where you have steps in a pipeline which each step could have one up to one and whatever many threads, and they are all synchronized in the pipeline. If you ever use this kind of approach in your application, you will never use this barebone feature. And I think I've also implemented the async await stuff in my, to make some advertisement in my FireMonkey development kit, because I needed the stuff in some places. But it's, if you're a bare-bone Delphi single-threaded, do everything in main UI thread developer, and you have to think in this kind of different way, where you do asynchronous stuff, you have async await, you have to start a thread, give a callback, and then this is really a different kind of development. You have to rethink what you're doing, and I think that is the main problem. You could not just take your 10, 20, 30 years old application in Delphi and say, okay, I now use threads, and I use this unit goes in this thread, and this unit goes in this thread. This is not how it works, of course. You have to rethink your workflow completely.
If I may return a bit here. So Omnithread library uses Delphi's T-thread and cannot do anything more than Delphi can do. So, but I would like to return to async await from C#. Olaf summed it up very nicely, but I would like to expose one other point here. So when C# compiler finds async await, it basically splits your method into multiple parts. You don't see it, but it does it. And then it creates a whole state machine which says, if this is executed, I will go to this state, I will now execute this part, and when it is finished, I will trigger an event, and blah, 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 blah. and it gets very complicated very quickly. But at the end, it does nothing more than what we do in Delphi manually. We trigger an event at the end and say, when this asynchronous part is completed, queue this event to the main thread so it can continue with the execution. So we do this factorization manually. In CSharp, it is done by the compiler, but the end result is actually the same.
Hopefully my audio is better now. Can you guys hear me?
Yes, but
we can hear you. It's
a little bit strange.
All right, well,
not better.
the question here is, why have we not switched to a multi-threaded app model for all starting apps in Delphi? And I guess maybe that's a good question is now when someone makes a new application in Delphi, it actually has more than one thread in the application itself, but all the code writing is in the main thread. What would be like the minimum someone needs to know to get started in writing a more responsive application with Delphi?
You have to know what can go wrong first. So that's the answer to the question why we are not doing this, because when you start writing multi-threaded code, your life gets more complicated very quickly. So I don't know, maybe we can do the two of my slides, which were meant as an intro to these kinds of problems. They're after the Parnassus parallel debugger, Jim.
Okay, yeah. I love where the slides are up now. The time is what keeps everything from happening at once. I love that.
Yeah, it's a tricky quote to find because mostly it's attributed to Einstein, but it wasn't said by Einstein. It comes from a science fiction short story, of course. But in my head, that's what multi-threading is. When you run your normal program, you run through a single thread of time. Everything is executing sequentially. Nothing weird is going on. And then you start parallel programming and you fall into a multiverse. And when you want to grab a cup of tea, your other you from the other thread tries to do the same and fights with you for this cup of tea. So when we go to a single thread, we basically create a mini single threaded program inside your big program. And with that, we try to make stuff execute in parallel, but not so complicated. We'll see on the next slide what I want to mean. So if you click this. So now we have multiple simple computers basically running inside your code. Each one is a single thread, each one executes sequentially, doesn't have any problems, but then they start working on the shared data. They want to grab my cup of tea, and we have problems. And that's why your normal Delphi program is not multi-threaded, except if hidden somewhere deeply in the runtime library and not exposed to the general user. Because those kinds of problems are so numerous, you cannot write bug-free multi-threaded code even after, I don't know, 20 years. When you think you know everything, you write a simple piece of code and you shoot yourself in the foot. So good, you're angry for 2 weeks. But if you can separate your input data into multiple parts and then work on them, and then somehow aggregate the output results together back again, then the life is good because each thread will be working on small subset of data they will not find with them, with each other, sorry. And multi-threaded programming will get safer, let's say. And for example, that's something that tparallel.for in parallel programming library does. You say tparallel.for input value, lower bound, upper bound, and some code. And the very, very, very complicated code which runs this tparallel.for will split your input data, that range of numbers, into parts. and run your threads on them. So maybe they will not fight with each other. I say maybe. Because in every real code, and as my colleagues have said, we have real-time code from 20 years ago, which knows nothing about threads. This code works with global stuff all over the time, all the time. You cannot do anything without working with some global stuff, typically. So you have these interaction points when threads are fighting for the same data. Again, my cup of tea is the shared data, my global cup of tea. And something that will come now too, I think, we were at this point. You have two general ideas how to solve this problem. And one is synchronization. The code must say, hey, this is my cup of tea. I will grab this cup of tea, I will drink it, I will put it back. Now you can have it for yourself. Problem with this, you have to do it manually in your code. And if you mess up, you get deadlocks when two threads start waiting on each other and everything stops. Or you forget to do this in one thread and it will corrupt everything for all those other threads which are nicely using synchronization. And more and more and more and more problems. You will have to do it at the end. There's practically no way you will write a serious multi-threaded program without any synchronization somewhere. But you should try to minimize this because it's a very, very nice point of failure. The other way is communication. So library handles this stuff, and you use library to say, please task, work on this part of code or data, and when you are done, please return me the result. And in your main thread, you just do the aggregation, just sum everything together. So with my cup of tea example, I only need the initial split. I have to pour this into two smaller cups and give each cup to each thread, and they will not fight with each other. And the art of multi-threaded programming is exactly this: how to split your data, how to aggregate your data, and how to do your synchronization when you cannot do that. So that's as an intro now. Please expand on this.
It's easy to start with small things if you're starting. For example, retrieving some data from a web service, something that doesn't have any shared data. You have an URL, you send it to the server, you have your results back, and there is no shared data in that scenario. So you are safe, and you're safe to when you're starting doing things like that. This is easy start for everyone. And then later on, when you learn more, you can start doing more complicated things and share data on larger scale. But sharing data is always a problem. That can be extremely complicated, depending on, of course.
I think for the first try. Sorry.
Please, please go ahead.
I think the best way to start with using threads is to place, we call it Goodweather code here. It's a nice term from Bernd Uhr. Goodweather code means you just put code into a thread or into TTaskRun where you expect that you don't get or nearly don't get an exception, that the code run itself and it runs only for a limited time. If you start with this kind of approach to use threads, you are nearly safe. You can do many things wrong, and we also have some questions in our backlog here about what is thread safe. And I think what is thread safe is really the main topic we should discuss, because to say my code is thread safe, this is only true if your code is not depending on anything. Let's say if you call an into string and you don't know exactly what into string is doing in the background, there might be some stuff involved, like or formatting a datetime value, where the datetime value function have to pull the formats and everything else. And in this case, this is already not thread safe if you don't take a look into the runtime library. So thread safety, I think it's a really big major problem. And from my point, I'm doing threads since the first day, and to call something thread safe is like call something thread safe for 99%. There's a chance of nearly 1% that the code you might think it's thread safe is not safe, thread safe in a corner case or whatever.
Yeah, there is
I took something from a question here from Michael Lee High, and he says that he found something in the documentation, which I just copied from his question and put it into an actual Delphi instance here, just to show you, or to show the attendees what we are really talking about. So he asked, what the heck is this code actually doing here? So this is basically a very simple example taken from the doc wiki, and we have a T-task here. That's what we are talking about, and that will create a thread in the background. And so what is thread safetiness? Pardon me?
Or maybe not. The thread is possibly already running. So as we
no,
talked
in
before,
this case, the thread is the T-task is just created, and we have a separated start call here. So this is the longer version of just issuing a TTaskRun. So this really doesn't matter here. But the question is, what exactly is thread safe and what not? So here in this case, we are accessing the UI. Showing a message is UI stuff, and you cannot access anything from the UI from a background thread. So everything in between these procedure and code is somehow executed in a background thread. That's something T-task takes care of in some way. The technical details do not really matter here. So the sleep code is just a stupid example for, well, we do something that takes a long time. So this could be a call to a REST API. Pardon me?
So I don't have to wait 3 seconds to execute the show? I'm just kidding.
Well, a better example.
So when we click the button, so obviously there is an extremely complex UI here. So we have a button, and that's what when we click on it. So what do you think what would happen? Well, the code executes, and after 3 seconds, we will see a show message or a message saying hello, because this is a delay of 3 seconds. This is just 3 seconds working on some stuff here, and then we will show the message. So after 3 seconds, roundabout, we will see the message. But this is basically telling the code inside this procedure here to, well, make sure it's not executed in this very background thread, but in the main thread. This is basically what the synchronization call does here. T-thread synchronize means, well, hand over the code that I'm putting in here to the main thread as soon as the main thread comes available, of course. So if the main thread is busy with something else, this code will wait until then and block, of course. And then once it could hand over to the main thread, the code inside the begin end here is then executed safely in the main thread. So this is the purpose of the synchronization call that we see in here. So this is taken from a simplified example from the documentation, and still there are questions what exactly is going on here. So just to show everybody that it's really happening here, I didn't try it, I just typed this in while you were talking here. So we wait 1, 2, 3, and maybe a little bit longer, and here is the hello. So if you look closely, I can move the window, and it doesn't come And here we go. So if I didn't have the T-task, the window will become unresponsive, waiting 3 seconds, and then show the message. So this is basically what this is.
Okay, best change to this little example is if you just do in line 31 first button 1 enabled to false, and after the show message button 1 enabled to true, because this is let's say the main pattern how you should use a button click in FireMonkey, because for get a user response on a mobile device where you click on a button, first you have to do is button disabled, so the user couldn't push the button twice, and then as soon as possible leave this on click procedure, because FireMonkey wants to make his timer stuff to display the animation for pressing the button and releasing the button, and all this stuff is using the main thread. So if you are doing this kind of stuff in FireMonkey, just disable the button, create a thread, and leave this procedure as soon as possible.
Yeah,
And
so disabling it prevents someone from double clicking.
Exactly. So if we didn't do that, we would have happy users, happy click users. Oh, this is, what is this? I don't know. I just stopped the whole thing.
You closed the window before the thread was finished.
Yes.
Yeah,
Yeah,
right.
and you show one problem we all have with this kind of
that is intentional.
not good weather code.
Yeah. And if we didn't disable, like Frank suggested, we can click it many times, and we will have, of course, many show messages. So this is certainly not what you want. You see, it's actually, so it's 1, 2, 3, 4, 5, whatever. So yeah, it's essential in that case to do exactly how Frank suggested.
And you get a lot of overhead, because you have done the perfect example which you have to consider when using this kind of approach. With this kind of code, you have to say can close to false and prevent the application for terminating while the thread is running.
Right.
Okay, I see here in questions, is calling sleep a good practice inside of code in separate thread task? So in this example, sleep is just a replacement for some actual work, which the documentation writer didn't bother to code. In reality, you can safely put sleep into your threads, yes. Sometimes you would want to do that. Just know that during the sleep, your thread sleeps, or your task or whatever.
Yes.
So even if you have some termination mechanism when you can say to the thread, please stop now, because the program will shut down, and your thread is executing your sleep, the thread will not see this request, because remember, as I said before, each thread is a single-threaded program. It can do only one thing. If it is sleeping, it is sleeping. But I see this question a lot on my talks. How do you terminate a thread which is doing something else? You cannot. You can politely ask a thread, please terminate at your convenience, or you can kill it, which is a very, very bad practice.
Very bad practice.
Yes.
Very, very, very.
Sleep is also usually used incorrectly when people, in this example, this is okay because we don't actually want to do any work in the background. We just want to see the delay between starting clicking the button and showing the message. But people usually, often, not always, use sleep for measuring performance, and that is not a good thing, because sleeping thread does nothing. So if you want to measure performance, you have to do some actual work in the background. You cannot just sleep.
Yeah.
Yeah, and of course, never do something like repeat sleep until something. In this case, use an event to handle this. And of course, you always see something like a repeat until, and in the repeat until you have application process message. Of course, inside a thread, you can't use application process message because this would trigger the UI thread.
Yeah, the reason for this is partly the Delphi 2 documentation, which said we are using threads by calling tthread_create, and then we write execute method, and inside we do while true do blah blah blah. And then this somehow stayed with lots of people for a long time. So you never want your codes to do busy work. Either it should do something or wait on something, not check. If you can avoid it, of course.
If you have a form, for example, and the form itself, normally I don't want to say this because doing all in the form is very bad. That's why I'm using this MVVM stuff. But normally you create a form, and if the form uses some kind of threading, and you hit a button and the thread's doing something, and you want to close the form, and you have some termination code for the thread where you call thread.free, and the thread.free depends on the flag terminated that is managed inside the thread code, and this only get recognized by the thread if you are inside the execute loop and check this, or if your application, which is called calculating the prime from 0 to 1 million, checks this in between if the thread tries to terminate. And that's the major point. Normally, you don't want to do this kind of long-running threads in a form, because if you want to close the form and hit the X button or just modal close whatever, it takes some time to terminate the thread. So in this case, I rather create a thread as an interface, and just set the interface on true on nil, but not wait that the thread is actually terminated. Just takes this as a signal inside a thread that the worker thread has to terminate. And in this case, you can close the window, and the instance is living inside this interfaced object. And if it's done, it's done. And like you have the feature of free and terminate, which you can use in a normal T-thread class.
Yeah, as it turns out, in multi-threaded programming, terminating stuff and cleaning up at the end is the hardest thing, even when you do everything correctly. Really, I ran in this lots of times when writing only to the library, when doing normal work. I had some discussion with Stefan Glinke just a week ago about this topic, because he came onto the same problem, and shutting down cleanly is very hard sometimes.
I had a talk with Stefan 2 weeks ago about interfaces and weak references of threads inside an application, because the weak attribute you can use for an interface is, of course, not thread safe, because the mechanism behind these weak references to inform that the original instance got nailed is after the instant is, or while the instant is terminating, but this call is not thread safe.
Well, that problem goes much deeper. It is not just that weak references are not thread safe. You can strong references are also not thread safe. So
yeah, of course. But this was the topic.
You cannot assign one interface reference to another interface reference thread safely, and this is the main problem why weak references also don't work.
Yeah, you can overcome this problem with interlock exchange for interfaces. this works not so bad. But imagine you have a thread running and you check if your weak instance of something, and you check if this is nil, and it's not nil, and in the next line of code you say, okay, this instance do something, but in between you check the nil of the weak reference, and the next line the original object could gone out of scope because from a different thread that's killing this instance. And
Yes.
yeah, you have to synchronize it externally. But yeah, these are the points where you say, if you're a newcomer to threads, don't try this. Don't do that at home.
Okay.
Oh, there's a question here
I have
about.
this on screen. Can I answer a question from the audience? Because I see here T-thread synchronize or T-thread queue by Robert Evans.
Yeah.
In almost all cases, T-thread.queue. This should be fixed here, because there's only one good reason for synchronize: if you want to get a result back from the main thread and do something with it later in your background thread. The difference is that synchronize stops your thread execution, blocks it, and then waits until main thread processes this and executes this code, and only then the thread will continue running. In this case, there's no, okay, now Jim has changed it. But in most cases, you can just say queue. Queue will just push your code into some queue, and the main thread will execute it later. And in this case, I would do queue, definitely. The task just says, I'm finished. It doesn't matter whether the task is running or not when this small show message button enabled code executes. So this is definitely a queue here.
Yeah,
yes,
like you see in the example here. I mean,
Yeah.
With synchronize blocks and queue doesn't block. So here in this case, we will execute the sleep call. Then we will wait to show the message. And after the user hit the OK button, then this other stuff will be executed. So if the other stuff depends on what's happening in here, then you will need a synchronize. If this is completely independent of what's inside here, you would just write queue, and this call wouldn't be blocking. So that's in simple words.
Except on FireMonkey.
You also need to use synchronize if you need to clean up some local variable, some data that you need to release, or you can transfer the ownership to the to the queue. But if you have some more complex cleanup, and you need to use that data in the synchronize method or queue, then you cannot use queue because your cleanup will kill that data. So you will have to use synchronize. But generally, queue is better because it doesn't block the thread, like pretty much.
Yeah, but with a I-24, it's not the problem. But if you are using, like, let's say, an instance descent from T-object, you're not aware that T-object is already out of scope if the executed queue will synchronize with the main thread. So in this case, you have to build a closure to maintain the instance of the object until the queue is finished.
Yes, if you have if you create object in thread and you use that object in a queue method and you clean up that object in after your threaded code has finished, then you cannot use queue because you will clean it up after before the queue method has chance to run the code. So if you have such a situation, then you have to pay attention to, or use something, don't use local data and use global or whatever.
Terminating threads is hard.
It's actually a very common error, like I have here. So there is a local variable, and you think you would access that in the queue call. Well, basically you will access I, but here we are resetting I to a different value. So which value will the message show? Well, hard to say. Depends on how fast the thread starts and if we already executed this one, if we are doing a queue call. So in this case here, if you want actually to show hello 42, it should be a synchronized call, because it's basically how the your logic is actually, or seems to be designed here. So
actually, as Marco would say, I disagree. So in this case, I would create.
Don't forget, it's a very simple example. It's an oversimplified example.
Yeah,
it's only intended here to see that you cannot just rely on variables in a queue call. That's the problem.
Most definitely, but you can grab. You can create, as I think you said, you can capture this value at this point by writing additional local function which generates
TProc.
Yeah,
you create a closure
and
over
then,
exactly.
And
that's the exact point.
That's the problem of the capturing mechanism, not the problem of queue.
Well, that is the problem. You have some example and you simply change a little piece and it all falls apart. So you have to take care of every little thing you are doing, because slight changes suddenly turn out your code from working to non-working.
Olaf, can you run your example code there? Maybe add a sleep right before the show message just to see
sure.
how you might change with queue versus synchronized.
So this is synchronized. So we are waiting 3 seconds. Well, I could have removed that one. Hello 42. And now we make that a queue call. So it's 3 seconds just to keep the cliffhanger, and we're seeing 4711.
Yeah, so are you sure that you're seeing 4711 like the Kölnisch Wasser?
No,
because
I'm not.
You have a reference still to this memory address?
Yes,
because it's a
capture mechanism captures the memory location, not the value at that point in time.
Exactly.
Right.
Exactly. It's a common misunderstanding.
And because it's a captured variable, it will not be just on the local stack. So you have access to it after
because it's not on the it's not on the local stack. You can use var on the button click or in the TTaskRun procedure, but maybe in this case you are lucky that the I address and the memory at this address is still valid.
That will always be valid. That is an anonymous method is backed by interface reference, and that variable you're capturing is actually filled in that hidden class behind it. So it will always be valid as long as anonymous method is valid. From that standpoint, you don't have to worry about that. But in this case, we have integer, which is value type, so we don't have to worry about its lifetime. But if you capture object variable and you free it in this code, if you would free that object, you will have a dangling pointer in the queue method.
Yeah, so that's my point.
Because you have captured the location of the object reference, but the object itself allocated on the heap is gone at that point.
So Kevir had something he started to say earlier and got cut off, and I'm going to jump back to you if you remember what it was you're going to say, Kevir.
I was only say that when you use show message on mobile platforms, it might be asynchronous, so that the example we were saying a few minutes ago might not be valid, because even when you're using the synchronize, your code will still running because the dialog wouldn't wait for the user to click on it.
Because all message calls in mobile are asynchronous. Yeah.
Yeah, that's true.
it probably caused some confusion, but it was just an observation.
So this show result should use tthread.q for the demo, I think.
Okay. So
Go ahead, Promoz. What were you gonna say?
Just this. So for this demo, we need tthread.q here.
Oh, okay, got it. I will comment though, during the webinar we had a couple weeks ago with Dahlia, one of the things I heard answer coming up to a lot of questions was write a test and find out, because so often until you actually write some code and test the behavior, it doesn't.
For right line, you need console application.
Yes, there is one thing with multi-threading and testing. You cannot reason whether something is thread safe or not just by testing. If it crashes, then you are lucky, you know it is not thread safe. But you cannot say it is thread safe because it doesn't crash. You have to reason with logic and see how your shared data behaves, whether you are sharing data, whether you are not sharing it. And if you are sharing it, is the data protected? And you have to think about that. You cannot just run a test, because test may run successfully and then your application can crash in the real life.
Yeah, you should test a lot.
Always the proof.
You should test a lot and for a long time with many repetitions, because problems will only appear from time to time, typically.
Yes.
So this should be a show message.
If you don't have a problem, you still are not. You still cannot say that you are completely safe.
Yeah.
That is why it is so hard, because if you cannot find a logical error, and even if you test a lot, you are not always 100% sure that it is correct.
I say that unit test will show you that your single-threaded code has obviously no errors, but they will only show that you have no obvious errors for multi-threaded code.
And unit test with threading is a different topic we should cover in a separate session.
So this works now.
There's an answer from Ivan Sugent, as Olaf said.
Yes.
Yeah. He asked how to call the terminate if he has a thread inside a form. So you normally don't call terminate by yourself. You just free the thread instant, and the free instance calls terminate inside the destructor call, and this informs your TTask, your execution procedure, that the flag terminated is set, and then you have to exit the loop of the execution method. And if you do this in the form close, the form is closed after the thread is terminated. So your main thread have to wait to close this thread. And as I mentioned before, this is normally not wanted, because if you hit the close, you want to close the form directly and not wait for the termination of a long-running thread. But we can keep this in mind and do another blog post or topic about that.
Actually, I was glad you brought that up. That was the question I was going to ask next. So there's a few things in there to unpack. So you're saying that on a thread, you should call free on the instance, and then the free calls the terminate, but then inside the thread should check to see if the terminate flag has been set, and then it should terminate itself. Is that accurate?
Yes.
Yes. But terminate or calling free on a thread calls the wait for termination. So if your thread doesn't terminate, your form will be stuck at closing.
Yeah.
Shutting down is hard.
That's the main point. You can call terminate, you can call 3, but you can call terminates if the form doesn't own that thread. Then you can call terminate so that you stop what the thread is doing. But if you're also freeing that thread because form owns the thread, this is not ideal situation because you will cause delay when closing. So it is the best that you don't have forms that own threads and that free threads. You can call terminate, but that is not waiting on a thread. That is just signaling the thread that it is no longer needed.
I think that's a really important point, is that when you call terminate on a thread, you're not actually killing the thread. You're setting a flag that the thread internally can then say, oh, I've been terminated, and the code you've written in the thread can then respond to that and exit the thread.
Yep.
Right?
Yes.
Because a thread is a single threaded program, it can just check from time to time whether it should terminate and then react. I have another question here from the public. Can I send values from the main program to the threads? Yes, but you have to do some work. In parallel programming library, it is best to set up T-threaded queue, if I remember correctly, of T, and then put the data into it in one thread and read from it from another thread. I have an example of that in my patterns book, and the code is on GitHub. So if you contact me after that, I can push a link to this example. In OmniThread library, you do taskcontrol.com.send, and you send your data to the thread. It's a bit different. Or you can set up a queue. Or you set up a pipeline pattern, which is probably the best idea. And we talked about this before. In pipeline pattern, your thread is doing nothing more but just reading from a queue and then reacting to values. But again, you need a queue.
Olaf, I'm going to just show my screen real quick. I shared my slides, but I wanted to show just the resources slide here. There we go. Hopefully it's showing my screen now. The slides I've shared, those I'll share them again, though. Here you can find a link to the resources. And Promoz and others, if you want to, I'll add another slide for more resources if you want to include some other things in here, and that way I can publish a more detailed list of resources to people as well. So do check these out. There's a lot of good resources in here, and I put some others in the chat window as well. So I can switch back to you now, Olaf, if you want to show some more code there. I appreciate you doing that. And thank you for Promoz. That was the next question I was going to ask, is how to move data between threads. That's the other tricky thing, right?
Send tools. So I sent a link to this code, which uses, which implements a pipeline pattern with parallel programming library, with just out of the box Delphi. So you can set data, send data from main thread to your worker thread, and then back from worker thread to main thread.
Fantastic. I know that. So I have heard a lot of people as well say that your books, the high performance and the design patterns, are fantastic books that people should definitely take a look at
Thank you.
for learning multithreaded. And also Dahlia's book as well on the topic, event-based and asynchronous programming. Between those three books, everybody goes out and reads those, you'll have probably all your questions answered.
If you read all those books, you have a good starting point, but
yes.
This is just beginning if you are beginning.
So Roland had a comment here. It says threading works differently when running in a VM versus running in a real machine. Yes, I actually was talking to a developer that all their VMs they created were had a single core assigned to them. So they were a single core VM, whereas their host machine and every other machine in existence pretty much today was a multi-threaded computer. It had multiple cores. So You can do multiple threads when you only have a single core, or when you only have without hyperthreading and all that other stuff. But it behaves fundamentally different based on if you have a multiple core system and such. So definitely test your code on as many scenarios as possible, because yeah.
When you're writing multi-threaded code, everything will affect it. Start another tab in Chrome and your code will work differently. You don't need the VM for that. But there's this problem that I think OS may choose a different length of a time slice for a program if it detects that it is running in a virtual machine, just to optimize everything differently. So this will again change how your code is executing. There's no actual change, so whatever you code is the same, just the bugs will manifest in a different way.
So I'm going to go back to Dahlia. You commented about that the form shouldn't own the T thread. What is the best way, if you're creating a T thread, who should own that thread? Or, and if you have something that should be owned by a form, what would be, should you use a T-task in that instance, or what would be your recommendation?
Well, T-task is better if you're running some shorter tasks that are related to a form, because those threads are owned by thread pool, and the thread pool will shut down when application shuts down. So you don't have to worry about handling the thread. But otherwise, you should have separate. You should separate your threads from the main form or other forms. Maybe you can have it in main form if the main form is some handler, final handler, but you definitely don't want to have owned threads in some dialogues and secondary forms. So when you shut down main application, you can show some waiting for shutdown, some message to the user that application is shutting down, and at that point it doesn't matter. But if you have some secondary form, you want that form to be closed fast.
Okay.
So the idea of a form owns a thread is one thing you can do, but in case we are all not happy with these red button double click code inside it, we should use of course different approaches, but let's stick with this approach. You have a button, you open a form, the form creates a thread, and you want a rapid close on this form, whatever the thread is doing. So you have to create an instance that is maintained by itself, which is like a class that is T-interface driven. So if you have a worker thread inside a T-task, inside an object which is interface referenced, you can of course set on close of the form the interface reference to nil. What you don't do in this nil call or in the destructor of this class is try to free the original thread, because in this case you just have created a wrapper that doing the same with one layer above. And the trick is you have an interfaced object, and inside you have also an interfaced worker thread. And while kneeling the outer shell, the outer wrapper, you just get the information from the main view, because the main view or the new form sets this instance to nil, that the user wants to close this running thread. By using this information, you must immediately return and do nothing more inside this destructor of this class, just inform the other thread to terminate, but keep the reference of the wrapper inside itself. And that is the trick. You create a thread wrapper which has its own interface inside. So by kneeling the outer object in, or just free it in your form, you inform the inside worker that it has to terminate. The inside worker itself has an interface reference to itself and just get informed over the terminate that it should have to terminate. And then this object is like a singleton run instance that is somewhere in the memory, and your application could close the form. And if the thread terminated is done, it just creates its own interface reference and frees everything.
You mean you are creating a reference cycle with itself?
Right.
Yes. Okay. Yes. That should work, because you create a reference cycle to yourself and you keep yourself alive until you are terminated.
Right.
Yes.
And that's so you are able to close the form with no delay for waiting for the thread termination.
Question here about using live bindings and how that in FireMonkey and how that impacts.
Don't
your,
use it.
Yeah, that's the problem. or at least don't bind
could
until your
we all
data
agree
set
to
is
this?
completed.
Sorry, what's that, Calvert?
Don't bind until your data set is completed.
Oh, until your data set is populated, yeah. So
well, live binding is not thread safe for the start, so you cannot use them for background operations.
Okay, yeah, they're not work for background operations. I was just going to say, live bindings, it works good in certain situations, but then when you start to have issues where you're synchronizing data in different threads and stuff like that, then you definitely, because it takes some things out of your control, you're better off not doing that.
Yeah, Jim, you've recently published a video about doing a Stack Overflow REST request in Delphi, and yes, this was a perfect example for advertising Delphi's capability of doing REST calls and everything else. And this is overall one of the best videos I saw to show non-Delphi developers how powerful Delphi is. And in this case, you also use the live bindings. And so my point is you can use live bindings for this kind of small proof of concepts. But as I'm only doing MVVM, I'm never use live bindings. And okay, that's my point.
I thought you were going to say that I had a race condition in my video or something. I was like, oh no.
Yeah, but this was a perfect demonstration how powerful Delphi could be.
Yeah, because I was in that video. You're right. I am doing everything in the main thread, and so technically I would be blocking, and so I probably should have put some stuff in the background thread because it probably takes too long. But for a simple example, you're right. That does work. I did want to share my screen real quick again. I have a oops, I don't have it up here. I wanted to point out the Parnassus Parallel Debugger, just in case anybody wasn't familiar with that. This is a new plugin that's available in Git that adds a lot of really cool features around parallel debugging and actually improving debugging in general. Have any of you used the Parnassus Parallel Debugger yet, and any comments or impressions on it?
Yeah, it's a beautiful stuff. I was involved in alpha testing with David.
Yeah.
Promptly killed his plugin because my program started and it created, I don't know, 80 threads. And his task and list displaying code just died, sadly. But I have to make it better and faster, I think. And now it's a beautiful plugin. I really love it.
Yeah,
It has
interesting.
It has one great option, which is not part of the Delphi. In normal Delphi, when you debug parallel code and you press F8, for example, to step to the next line, all threads will activate at that moment. And if some other thread raises an exception or hits a breakpoint in the code, your execution will switch to this other thread. And then you of course have no idea in which thread you were before. You will never be able to find it in the thread list and so on. And with David's plugin, you have a buttons. Where is now the screen, Jim? You have a nice list of buttons, a row of buttons in every thread panel. Put it back so that people will know what I'm talking about. So about the call stack, we see 3 threads here. You have a nice row of buttons. And those buttons step over or step into the procedure. So they do F7 and F8 and so on, only for the thread you are debugging. They will keep all other threads frozen at that moment. So your debugging is faster because nothing else is executing in the background, and it is safer because nothing else is executing in the background, and you can get more relevant data maybe because nothing else is executing in the background. So this alone is worth installing this plugin. Plus you get great display of everything.
To be honest, I did not find the time to test it by myself. So my stupid question, is this also usable with mobile debugging?
I have no idea. I'm strictly Windows developer.
Okay.
I believe so. It seems like I did test it with mobile, but I'm pretty sure it is. I'm pretty sure it is works on across mobile as well.
Some functions may not work on mobile, maybe, but it should be useful in general.
That I honestly don't do a lot of multi-threaded code currently, and I was like, I'll take a look at it, but I don't know that I'll find it very useful. But I actually did find it useful even in simple, fairly simple single-threaded code as well. I think it improves debugging in general, especially for multi-threaded. And it's free and get it, so highly recommended. Glenn just commented, excellent for first version, yes. So here's a comment here about live bindings being thread safe because you're open, for example, SQL query in a thread, but to show the result, you will access the UI. So yeah, they're great for, you work for simple demos, but not for more complicated things.
So there was a question about implementation of async await. I can just switch to my desk, I think. Jim, could you share my desk, or should I?
Yep. Hold on a second. I will share your screen. Sorry. There you go. You should have control now.
Okay, so
can you make your font possibly smaller? Sorry, you clearly have a high resolution display.
I'm sorry. This
there
is part of my FireMonkey development kit, and you see the main topic here is this threading stuff. It's async await, async task, thread safe queues, pipelines, serializer, simple threads, timeout worker, and all this stuff. All this stuff would exceed the session for tonight, I think. So if you want to see more about this, just write me a comment or just hit me with an email. It's frank@delphiprofi.com or .de, and I can probably do a blog post on your request. So if you are interested in seeing more of this threading implementation, I can do a blog post of it and present some example code if you like to see the implementation or some kind of hidden stuff I used in my development kit.
And I know that.
Sorry, before I find the time to check this parallel debugger, one really necessary toolkit you have to in your toolbox is a logger implementation, and the logger implementation should be thread safe. So to find problems in threading implementation, a thread safe logger is a key. So you have to use a logger which is able to get logging entries from threads, main thread, whatever thread, and present it to console, debug file, whatever you like, or smart inspect or test inside, as for example. I love Stefan Glienke's test inside. I would never develop any kind of unit test without this tool. And one part is if you're try to find debug or you have to implement unit test for your threaded code, I have a logger to be able to put log messages inside the test inside a tool from Stefan, and that is very helpful. You can write your unit test and do something, and also get the log information inside this logger window. So if you want more information on that, just hit me with an email, please.
I was going to say, Frank, it might be, I don't know if I've talked about this before or not. I know that we've done some videos in the past with Promoz and his Omnithread library. I think we did, actually. Yeah, we did. We have. Might be good to get you on do a demo with showing off your library and how to use it and stuff like that, and how people can take advantage of those.
Yeah, I have some stuff on my YouTube channel, but at the moment I'm focused to get my MVVM framework ready, and that's why I've not uploaded a video quite some time. And but the plans are going on, so if my MVVM is done, I would like to do at least 2 videos a month, so every 2 weeks a new video explaining all the units. It's more than 145 units currently collected in my FireMonkey development kit. And for everybody don't know this this kit, the name is a little bit stupid because of course you can use this kit also for VCL, but it started with, I started this kit with FireMonkey, but let's say 95% of these units are also usable in VCL applications. And this is the same with the MVVM project. Olaf and I had really deep thoughts about the implementation, how to be able to take a legacy application and convert it to an MVVM application with FireMonkey and also with VCL, and of course with the same code base. So key part is the MVVM framework. On top, you can use my FireMonkey development with all the fancy features. And the main idea was you have one view model and you have one model, and you have just to switch between the views. And you have to switch with the views with one line of code, and you'll be able to run your code in VCL and FMX on every platform, and that's the goal. And I'm little behind my schedule to finish this stuff because my main job triggers me, and of course the virus stuff had opened some new complication in management my company, but I'm fine, and I hope next month I could start over and finish this. And after that, Jim, we are talking about webinars.
Yes. The question here about what is a yarn or fiber? We've heard conversations about that, and how does that relate to threads and tasks? Anybody? I believe my understanding is a yarn or a fiber.
Fiber. Fiber is very, very, very low-level operating system stuff, which basically helps you do some manual time slicing inside your application. So your program, or actually one of your threads, can manually switch from a fiber to a fiber. That's a Windows term, and Windows specific, I think, is fiber. And with this, you somehow switch a context inside the thread. So you have something which is very fast. So those switches are very fast, but also very manual. It allows your program to think about multiple topics at the same time somehow, and switches between them very, very, very quickly. But I never use them in any application ever. So I just know about the concept.
Okay.
One very well-known program is Microsoft SQL Server. They are using a fiber concept to, well, optimize, I guess, their performance.
There's another question here about IOCP. Is Delphi's implementation of threading using IOCP? Is that something?
I believe there was.
I believe. I don't really know.
Okay.
So.
Yeah, I believe there was something, but I'm not sure if at all it still works. I'm not sure.
Let's see what Google says.
Let's see. I'm just going through here to see if we've got the questions answered as we're wrapping up here. Is anything? Actually, I'm going to start with go around. If there's anything any of the panelists want to share. Carol Fleur, is there anything you would like to share that we didn't cover, or any tips or things that you wanted to bring up?
I think we can talk a little bit about the database connectivity. That it's something really common, especially when the developer is starting with threading, because we used to think in the beginning that thread is where I will solve my performance problems, and then we start using thread for everything, and including the database connection. And there are at least two really problems that we used to deal with in the beginning. There are that is try to share a database connection between the threads. This is a big problem. I don't know any database that accept multiple comments in a single connection simultaneously. So you should avoid to share the connection, except if you're using any kind of synchronization or semaphores, this kind of things, like a monitor or critical section. But when you understand this and start to use a connection per thread, you usually have another problem, that is a lot of connections in your application, and then it comes the connection pooling problem. So today with FireDAC, for example, it's really simple and easy to use connection pooling. And if the audience don't know, they should take a look on this, because it's a powerful feature on FireDAC, especially when you're dealing with threads, and it helps to solve this problem. So these are the 2 points I would like to bring that I think we didn't talk it yet.
Sure, that's true. Now, you said connection pool. That is a feature of FireDeck, right? It does have a connection pool in it.
Yeah.
Mhm.
Yeah, and
That's
it's really easy to set up. You only need to fill a couple of parameters, and you're ready to go.
I think last year I've done a webinar about this, especially if you're on the mobile platform and using the SQLite local database. Of course, the SQLite driver could be compiled with threading ability, but I think the best case scenario is if you think at all your database is not thread safe. So if you have like a singleton thread that is able to handle commands, you can use this thread with one connection to a database and queue your database commands in a thread safe queue. So you can deal from many threads, just create a command base on CRUD, so create, update, read, delete, and so on. And you can create a chunk of command and the necessary data associated with it, put it in a record or an interface class or whatever, put it in a queue, and your main database thread could handle all these commands. And if the data is ready, just fire a callback to the thread and display the data. I think that's the easiest task to deal with all this thread pooling and connection stuff. You can keep one connection, open. You don't have to permanently open a table, but you can keep the connection and just hit this command and query queue to do all your database stuff. Of course, this is my idea with not using any visual components with direct bindings, because we want to use threads for this.
Yeah, plus, sorry, test, because every time you are talking to a database, you're talking to some third-party layer. And I still remember, like, I don't know, 15 years ago, there were some versions of Firebird drivers which promptly crashed if you tried to establish connection from two threads at the same time. And the crash was somewhere in the DLL. You couldn't do nothing about that. And we had to add a critical section around the connection creating code. So never try to create two connections at the same time. But that was fixed later, but you never know what problem you can hit.
Yeah, perhaps I'm I'm stuck in the old days sometimes. So if I don't know exactly how the behavior is actual, I would stay on something I know. And if I have one connection, this should work.
Kevir, I'm not finding, someone asked about the FireDeck connection pools webinar. I'm not seeing that, so maybe we need to revisit that because I was not finding it. Okay, Frank, anything else? You were just adding some comments. Anything else you want to add before we wrap up here?
Sorry, say again.
You had just made some comments, but was there anything else you wanted to say before we wrap up?
Yeah, I think one good point is if you have a really big main application, you should try to implement threads, but don't try it with your working application your customers depend on. Just start with threading with little samples and grow from there. If you have something like your application is able to update itself over the internet, perhaps this is a good point to start. Create a thread on program start, check your web server, present a message, there's an update, download the update in the background, inform the user there's an update, and if it hits OK, you can exit the program, launch the installer, you download it or something like that. Don't do too many things in two different ways. Just start with a simple solution you can imagine and work from there up. Not try to do everything tomorrow we do everything in the background. Don't try that. Don't do that at home.
Yes, little steps. And
Dahlia.
you have to start with little steps and sample applications. You cannot just jump in your own application, especially if it is a big one.
Yeah. I think with that, Nick Hodges once said that any Delphi developer that when they create a new application isn't project 25 or higher, it hasn't done enough experimentation yet, or something like that. You know, that you really should have a lot of testing applications that you've created to test different behaviors and stuff. And I remember when I was a kid, actually. Sorry, I'm digressing a bit here, but my brother. I knew I wanted to be a computer programmer, and he said, "How can computer programming be a computer science, right? Because you're not discovering things." I'm like, "You're always discovering things." There is such a huge amount of permutations and variability in the way you do things that every new program you write, every variation, every bug you fix, every feature you add is creates a whole new set of variables that things change. I mean, yes, you have unit tests, integration tests, and all this stuff in there to try and manage it, but the complexity of it is very high. So the fact that we as humans are able to wrap our brains around this and do computer programming is pretty amazing. Promoz, anything you want to add here before we wrap up?
Yeah, a few things. So for a programmer who's new to multithreading, don't write threads. Pick whichever library you want. Use parallel programming library, use Omnithread library, use Cochin Async. I noticed someone mentioned in questions, and I have added link to resources, so you can check it out. Use Frank's library. Just don't create threads, because you will deal with the complicated stuff which was already solved, and you will deal with it completely unnecessarily. Write the code, not the plumbing the code requires. Second, if you think you know about multithreading,
think again.
Yes, you don't. And you dealt with resource protection and synchronization already. There's a nice little game on GitHub called the Deadlock Empire, and I will put a link into resources, and go there and see how easy it is to completely break a very, very, very simple parallel code. And the last thing that I would add is maybe sometimes you don't need to write multiple threads. Maybe sometimes you can launch a new process, which is completely separated from your process, and let that process do the work of multiple processes. Something like Chrome does, for example. One tab, one process. It gets resource hoggy as hell, but if you're solving something, maybe you can launch 4 processes which run in parallel. Maybe you don't need to write threads. They are very good answer to lots of questions, but they are not answer to all of the questions. And then they will make your life very complicated.
Actually, that reminds me of a comment that came in earlier that I don't think we answered completely. There was a question about how do you, if you have a T-thread you started and it is not responding because something in that thread has blocked it, how can you force it to shut down? Is the answer use a process instead, or is there some other thing you can do to force it to shut down?
If a thread doesn't want to shut down, you can only kill it. You cannot force it. Well, that's forcing it. But when you kill a thread, you leave lots of things in a very, very undefined state. For example, if this thread was just writing into a file, it was somewhere inside the kernel, inside some call, and then you kill it. And the file handle will be completely invalid after that, most probably. File will be maybe open, maybe not, maybe it will be half open, and so on and so on. So write your threads so they don't block.
Yeah.
Which is a problem, and sometimes I ran into this problem 2 times, I think, and always it was an external customer looking for help. Once it was unit testing. You are unit testing some code and the code may misbehave, and in this case it is completely valid to just kill the thread. This is not a production code. The result does not depend, well, this will not destroy your data, it will not kill the customer's computer, anything. Unit test may still be valid after that. And the other problem was some external library which blocked under some conditions. And the solution there was to create one thread which only talked to this library and did nothing else. And if it locked up, you could just pretty safely kill this thread and set it up again and load the library again. But if you can do without killing the thread, do without killing the thread.
Yes, I think Raymond Chen wrote about it, about killing a thread. Don't do it. Just you're leaving your computer in totally unstable state after that, and this is a no-go.
Well, we could probably say if you are in the need to kill a thread, then something is wrong with your code anyway. So it's probably better to solve that problem instead of thinking how to kill a thread.
Yeah, you're introducing a new problem. Yeah. Yeah. And then Olaf, anything you would add before we wrap up here?
Yeah, if you're writing multi-threaded code, really reread or revisit your code multiple times and check every line if you're trying to access a variable or resource or something. And if that single variable or resource could potentially be touched from some other place in your code, just try to look at it from different angles just to figure out if there could be a possible problem. And there will be problems.
We all agree on that.
We haven't touched some necessary parts for threads. So, like, we didn't discuss T-monitor, we didn't discuss critical section, we didn't discuss events, and there are many topics.
Create an animal thread.
Yeah, and create animal thread. Yes, also. So, feel free to hit me with an email if you have additional questions. So perhaps we could chain together and wrap up a nice blog post about this.
Yeah, multi-threaded programming is a week-long workshop only just to cover the basics.
Yeah, the intro to multi-threading.
Yeah. Part 1.
I love the comment here. It says, and actually I will modify it here from John. It says, you have a problem and you think multi-threading will help. And then I would change it to say, problem now to have you. Anyway, thank you so much, everybody, for being part of the panel. Thank you to all the attendees for your questions and for coming out here. I will do my best to get the replay and the link to all the resources published and available for you. There's a lot of great content out here. Definitely the books and libraries that are been maintained and contributed by our panelists here are a great place to start, as well as some of the videos and such as well. So thank you, everybody, and we'll talk to you all later. Take care.
All right, thank you, and have a good night.
Bye, everybody.